So you may have noticed this very unnatural stepping that's going on here on the particles. And if we take a look at the front view, so you can press spacebar 3 to look at the front view, you will notice this very evident stepping that's occurring. And this is relatively common with fast moving particles. So what's happening here is that each frame, the particles are being emitted, but they are all being emitted with the exact same initial velocity and at the exact same time. So we have two main options to alleviate this effect. One would be go back to the network properties and increase the substeps. For example, let's try increasing to 4 substeps. You will notice this is much better. We still have some lines here, but it's looking much better. The problem with the substep is that as we increase the substeps, also the simulation time will increase proportionately. So let's try doing another thing. First of all, I will bring back the substeps to 1. And now let's try adding a mass property for the particles. So I'll create some space here and I will lay down a pop property node. I will connect it and turn on the mass attribute. So the mass attribute is mainly used for rigid body simulations, but in this case we can also use it to give a little variance to the forces that are being applied to the particles. So let me show you what I mean. I will scroll down and look for this option, use Vex expression. And here under the presets button, I will look into randomize mass. So this will create a Vex snippet that will randomize the mass attribute between 0.7 and 1. So let me do this much more extreme. For example, from 0.4 to 1. So right now, if we press play, nothing really will happen. But what I'm going to do with this new value is for all my forces, I will turn off ignore mass. So I will turn off ignore mass for the rise force, and I will also turn off ignore mass for the drag. Now, if we go back to frame 1 and press play, you will notice how we're breaking up these lines because the upward force is not exactly the same for all the particles. The particles that have more mass will not be so easily pushed by the force, while the particles that have less mass will be pushed much more. Also with the drag force, the drag will have much more influence with particles with lower mass. So this will give a much greater breakup without the need of substeps. So maybe for our final simulation, we will need to increase the substeps, but probably just in a very small amount. So for now, let's go with this. And another thing that I want to do is change the shape of the emitter over time. So if you take a look now, through all the entire animation, the emitter has the exact same shape. So let's go up to the sub context, select our point VOP, and here under the offset attributes, I will add an HScript variable to the Y offset. So you can type $F, or actually let's use $T to change the Y offset with the time value. So let's press play. Let me highlight the point VOP, or actually the delete VOP, and press play. And since now the offset is being driven with the time variable, you will notice how the shape of the emitter is changing over time. So let's take a look at the particles. And this will give a much more natural motion.